Okay, so shall get started with the tutorial. Maybe this will just be 5 minutes. Okay, as much as possible, please try to solve them on your own. This is what we said in the previous class. What we will do is we will solve the problem for a case where reaction rate is second order. It can still be A giving products and the rate of reaction is second order in A. So that is the example that we will take. Okay, and the other question that the next question is, how do you get the value of Ka? Okay, so just remember that in minus out is given by Kc multiplied by Cab minus Cas. So you can think of Kc multiplied by Cab as in and Kc multiplied by Cas as out. So that's in minus out. Okay, plus the rate of formation of species because of reaction, which is nothing but the stoichiometric coefficient multiplied by Kca squared. Stoichiometric coefficient for A going to products is minus 1. Okay. So, therefore, you are going to have 0 equal to in minus out plus reaction formation because of reaction. Formation because of reaction is a negative value because it is a reactant that is getting consumed. Okay. That is essentially your balance. Keep in mind the balance is not on moles per unit volume per unit time, moles per unit mass per unit time, it is in terms of moles per unit time. Okay. So, if the rate of reaction is given in terms of per square meters of surface area, you have to multiply it by the area. If it is given per meter cube of the reactor, you have to multiply it by, it would not be given like that, but if it were given as per meter cube of reactor, you will have to multiply it with the volume of reactor. If it is given per meter cube of pellet, you will have to multiply it by meter cube of pellet. If it is given per kg of the catalyst, you will have to multiply it with the mass of catalyst. Okay. So that you eventually get the terms in terms of that expression in terms of moles per second or moles per hour or kilomoles per second, whatever might be. Okay. Now, the flux K multiplied by Ca minus Cas, the flux is in terms of moles per meter square surface per second. Okay. So, you will have to multiply the flux with the surface area. Okay. Always remember Kc is in terms of meters per second, concentration is in terms of moles per meter cube. So, meters per second multiplied by moles per meter cube is moles per meter square particle per second, or moles per meter square slab per second, or moles per meter square surface area of the catalyst per second. Okay. How do we get the value of Ka? That is either based on the expressions for Sherwood number or the expressions for the Chilton-Colburn J factors. Okay. Sherwood number is nothing but K multiplied by D divided by diffusivity. The diffusivity in the denominator is going to be the mixture average diffusivity. Okay. Either those values will be given to you, or how you can calculate that expression will be given to you. So that is how you can calculate your D. Your small d is the characteristic length, which is either the diameter, or it is going to be the hydraulic diameter, or it is going to be the thickness of the slab, or whatever the case might be. What d is, that information will also be given to you. Okay, remember that the Reynolds number is du rho by mu, Schmidt number is given over here, okay, and Prandtl number, Nusselt number, Schmidt number are all given, and your JD and SH expressions are also given to you. Okay. So that's how it's primarily, most of the time it's a matter of substituting in the right expression and getting the value of Sherwood number or JD, and from JD and Sherwood number you will then get the value of KC. Okay. That is how you are going to calculate. Okay. So those are the two problems that you are going to solve for today. Okay. So any questions? Okay. So you can get started if you have not already gotten started. As somebody had said, for quadratic expression, what you will have is you will get a term that is a quadratic equation. Okay, a quadratic equation might be in the form ACAS plus B, sorry, ACAS square plus BCAS plus C equal to 0. Then CAS is going to be minus B plus or minus square root of okay. Okay. So you will choose a solution which satisfies this particular criteria for straightforward problems like this. Okay. If you have multiple reactions, series parallel reactions and all that, then this particular part may not be satisfied, but this part will always be satisfied. Okay. So one of the solutions might be negative. So for example, if B is a positive value, negative B is definitely a negative value. So minus B minus square root of B square minus 4AC won't make sense. So you'll have to take minus B plus square root of B square minus 4AC. Okay. All right. Okay. Over to you. Please solve this problem. Okay, and again, when you are solving this when you are attempting all of this at home, you can look at Davis and Davis book. If you have not already done so, Davis and Davis book should be fine. If you have already started looking at Davis and Davis book, you can look at Froment and Bischoff also. Okay, all right. Thank you. Okay, so just quickly how to do the two problems. Okay, the first problem, flux due to mass transfer is Kc multiplied by Cab minus Cas in moles per meter square particle per second. Reaction term is minus 1 multiplied by or 0 equal to n minus out. Okay, so we have K dash Cas squared plus Kc Cas minus Kc Cab equal to 0. Okay, unknowns, these are unknowns, everything else is known. So therefore, Cas equal to minus B minus Kc plus or minus root of Kc squared plus or minus 4 into K dash into minus Kc into CAB divided by 2A, right. So, this minus and minus sign goes, becomes plus K dash Kc CAB. Okay. So, if you look at this, this particular value is going to be greater than Kc. So, we can safely use plus sign over here. This is going to be our CAS. Okay. Observed rate of reaction will either be K dash multiplied by CAS squared, or it will also be equal to this guy. So, whichever expression you want to use, you can use. Okay. So, R observed okay. So, that is how you can do. I do not know if that particular thing was asked or not in the question. Okay, red and black, just to uh, you know just so that you can visually see what those terms are. Okay. So, this term is CAS. Okay. Alternatively, you could have also written K dash multiplied by CAS squared, and if you did the math, you will find out that both of them will turn out to be the exact same expression. Okay. So, that is how you can solve the first problem. The way to solve the second problem, there is only one difference in the second problem. Okay. The mass transfer is Kc CAB minus CAS moles per meter square particle per second. Reaction is given as K multiplied by CAS. Okay. -1 is the stoichiometric coefficient. This is given in terms of moles per meter cube particle per second volume. Okay. So, 0 equal to in minus out Kc CAB minus CAS multiplied by A particle minus K CAS multiplied by V particle. Okay. So, this is going to be Kc AP by Vp or we can write this as this is your K dash. Okay. That is how you have to do. So, it is not just mere application of the formula if the formula is what you are used to. Okay. That is one of the issues. There is a very minor change compared to the standard formula, and because we are so used to using formula all the time rather than looking at the assumptions that are going in, we end up missing this point. Okay. Always remember, mass transfer rate is per meter square of area, reaction rate could be per meter square of area, per meter cube of particle, or per kg of particle. So, mass transfer rate will always be multiplied by the surface area. Reaction rate, if it is in R, it is multiplied by the volume. If it is R dash, it is multiplied by surface area. If it is R double dash, it is multiplied by the mass. Okay. And then you can do those comparisons. Okay. R double dash multiplied by rho is nothing but R. R dash multiplied by volume divided by area is R dash multiplied by area divided by volume is nothing but R. Okay. Those are the relations, and that's something that I had mentioned right in the beginning. Okay, let's say again you have to connect the different parts of thing. Okay, R is in kg per meter cube second, R dash is kg per meter square second, or sorry, moles. Kg of what? Kg of the catalyst. Okay. So, R multiplied by V catalyst equal to R dash multiplied by A catalyst equal to R double dash multiplied by mass of catalyst. You divide this by V cat, you will get R dash A by V catalyst rho catalyst. Okay. This is how they are related. Okay. And how do you get A by V? How do you get density? Density might be given to you. Area by volume, in this particular case it is spherical. So, area is 4 pi r square, volume is 4 by 3 pi r cubed. Okay. So, that is how you solve this. Slide number 25, 26, 27 is the solution procedure to the tutorial. Okay. So, yeah, I mean you can continue to work on this if you want, maybe submit it by tomorrow's class, okay, or submit it today if you are mostly done. Okay, and just one more thing, calculations in the exam would be of similar nature, but it will not be so tedious, in the sense that the concepts would be similar. Okay, the actual calculation would be simpler than this. Okay, the aim is, you know, it's a 2-hour exam. Aim is probably in 1.5 hours, 1 hour, 1.5 hours or so. If you have practiced well, in 1.5 hours you should be reasonably be able to answer the questions. That's how the exam is pitched. So 2 hours, based on my opinion, is going to be sufficient. I know that's not always the same. I mean, sitting over here versus standing over here versus sitting over there, perspectives are different. So, yeah. Okay. And again, there was a question asked. I mean, how do I prepare? Okay. The thing that I would suggest is your tutorial problems first, followed by maybe the solved problems in Davis and Davis, followed by the assignment problems. Those are the things that you would want to revise. Okay. All right.